Okay, today we're looking at what we look at as further inverse variation. So inverse variation that we've looked at y is proportional to 1 on x, but you know, any inverse variation is y is proportional to 1 over something, whatever that something might be. So, you know, you might have something like y is proportional to 1 on x squared, for example. You might have something like y is proportional to 1 on square root x, for example. Now, each of these things, when you draw them, are going to look on like that. Okay. Of course, depending on what the function is, the line's not necessarily exactly going to be, you know, there like that. You know, it may curve, you know, more steeply or less steeply, but it is, you know, to curve in that particular form. So for all of them, as one variable increases, the other decreases. So to get on the graphs, of course, the 1 on x squared, we need to graph y against 1 on x, and when we do that, we get a straight line. The x squared one, if we graphed y and 1 on x squared, then we would get a straight line. If we just graphed 1 on x, it still would be a curve. And that last example, we looked at y is on 1 on root x. To get that straight line, you would need to be graphing 1 on root x, and then you would get a straight line. Okay, so let's look at some examples. So, first example. Right, resistance R of a wire varies inversely as the square of the diameter D. So when D is 4 millimeters, R is 4 ohms. Now, resistance, wires, diameter, ohms, it makes no difference whatsoever whether you know what they are or what they aren't. You know, if you're doing physics, you'll find out a bit more about those things, but what they are is irrelevant. What is relevant is the mathematics. And the mathematics tells us that the resistance R varies inversely square of the diameter. So that's our mathematics. So our mathematics is telling us that. And so when we write down that, the resistance of a wire varies inversely as the square of the diameter. Maths. Okay, so that's all we need to know. So if that's the case, then our resistance would be equal to some constant over the diameter squared. Now we've got some information about that, because we're told that when our diameter is 4, so 4 squared, then our resistance is 4 ohms. Alright, so then we got 4 equals k on 16, and 4 lots of 16 would be 64, so k equals 64. Alright, so there we go. So I'm going to write that, just rub this out, because I'm going to refer to a few things written down in the question, so I want to keep that there. But as far as we know now, that our resistance is equal to 64 over our diameter squared. Alright, so let's get rid of all of that. Righto. Next example. So it says find A, the resistance when D is 1.2 centimetres. Okay, so there's our bit of information. Now I want to point something out that we need to look at, that you may or may not have already noticed, that those two units are different. Okay, this 64 was worked out using 4 millimetres. This 1.2 is not millimetres, but centimetres. We need to have these units that we've used, so this unit there and this unit there, we need to be working in the same ones. Okay, so for our diameter, that's 1.2 centimetres. It needs to be in millimetres for us to get the correct answer, because remember, this 64 here was worked out on millimetres, and so that's just 12 millimetres. So now that we've got that, we get that our resistance is 64 over 12 squared, and so that's 64 over 144, which of course is going to give us a decimal answer. Now, the thing is, in this subject, and particularly when next year when you get to specialist maths, the expectation is that everything is given in exact values unless you are told otherwise. So we need to leave that in a fraction form. But the other expectation, of course, is that it's all simplified. And so you need to simplify that down to 4/9. So the thing that will go into both of those, of course, would be 16. So the resistance there in part B is 4/9. Alright, on to part C. Let's get rid of that stuff there. Okay, so on to part C. And part C, R equals 64 over D squared. But of course, we're told the resistance here is 8 ohms. So 8 equals 64 over D squared. Quick bit of rearrangement, we get that D squared would be 64 on 8, which would be 8, I believe. And so D we'd get by square rooting 8. Now, the thing we need to look at is, it says correct to 2 decimal places, and so that's another thing that they're fussy about, specialists next year, is that you give your answer in the form that it's required. Now in this case, it is required correct to 2 decimal places. So if you put square root 8, or even simplify it to 2 root 2, and leave that as your answer, you will not get full marks. So you have to get your calculator out, and you have to do square root of 8, and when you do that you get quite a few decimal places, 2.828, and if you put down as 2.82, again you're not going to get full marks, because you know the expectation is that you know how to round correctly, and by the time you get to specialist maths in year 12, so 2.83. And you need units, millimetres in there as well. Forgot to write the units in part A, but you also need units, otherwise again you won't get full marks in year 12. Okay, so that's working with numbers, but sometimes you might be asked to find the effect. So here's an example. Okay, so we're told y is proportional to 1 on x, n is proportional to 1 on x squared, and p is proportional to 1 on root x. And we're asked to find the effect on y, m, and p when x is doubled. So what we're going to do is we do an a comparison. Okay, so let's look at y first of all. So if y is proportional to 1 on x, it equals k on x. Alright, and so that's our old. So let's call that old. Now our new one, what are we going to do? So x new is going to equal twice x old. So y old is k on x old. So y new then will be k over 2x old, and that would be a half k over x old, and x old, 1k over x old is a half of y old. So what's the effect? The effect is, for y is multiplied by a half divided by 2, however we want to describe it. Okay, so if we get rid of that and look at m now, so m old is equal to k over x old squared. So x new is equal to 2x old. So m new, the new m value is k over x new squared. Now x new squared is 2 times x old. Squared, which would be k over 4x old squared, which would be 1/4 k over x old squared, which is 1/4 of y old. Except it's not y, it is n old. So what is the effect? The effect is m is multiplied by 1/4 divided by 4, and so on. Alright, and finally the last one. When I rub all of this out, the last one is p, and p, the old p, is equal to k over the square root of the old x, and the new x is equal to 2 times the old x. So following the same sort of procedure, that the new p is equal to k over the square root of the new x, and the new x is related to the old x by twice the old one. So 1 over square root 2 k over root x old, and k over x old is the old p. So the new p is 1 over root 2 times the old p. So what's the relationship? The relationship is that p is multiplied by 1 on root 2 or divided by root 2, whatever. Alright, so there's our proportionality. So further. Alright, so that leads you to exercise 7D, which is problem set number 4, and that's on your sheet.